Hello, today I'm going to show you how to use the sine rule and the cosine rule to calculate a missing angle or a missing length of any triangle. I'm sure you're already able to use the basic trigonometry, which you may already call SOHCAHTOA, to find missing angles and missing lengths in right angle triangles. However, the sine rule and the cosine rule will enable you to find a missing length or a missing angle in any triangle. Before we start, I just need you to make sure that your calculator is in the right mode. So please can you make sure that your calculator has a D at the top of your calculator screen. If it doesn't, all you need to do is to press Shift, Mode Setup, and then press number 3, so you end up with degrees and you're working now in degrees. So here I have a triangle, I've drawn it out already, and you will notice that at each of the angles you have a capital letter, capital A, capital B and capital C. As you may already be able to see in my formula here, I've got lowercase letters and uppercase letters. What I need to know is where my lowercase letters sit on my diagram. To place my lowercase letters, it's always opposite the angle of where your uppercase letter is. So opposite my uppercase A, my angle here, my lowercase would be here. Opposite my uppercase letter B, my lowercase will be here. And finally, opposite my uppercase C, my lowercase c is here. So the formulae that we need to know to find a missing length, you're going to use A over sine A, which is equal to B over sine B, which is equal to C over sine C. All of these letters on the numerators are your lowercase letters, which relate to the lengths. You do not need all three to be able to work it out. All you will need is one pair of an uppercase and a lowercase, and one either uppercase to find a lowercase or a lowercase to find an uppercase. I'm hoping that this will make a little bit more sense when I show you an example in a second. To find a missing angle, all we've got is the reciprocals of the missing length formula. So sine A over little a, or lowercase a, sorry, sine B over lowercase b, and sine C over lowercase c. Now that I've given you these formulae, we are going to apply them to some examples. Here's my first example. Find the value of x. As you can see, x here is a length that we are looking for. So the first thing that I'm going to do is label my lengths and my angles. My angles have already been labelled for me, so all I need to do is to label my lengths. 16 is opposite my capital A, so that becomes my lowercase a. And the x is opposite my capital C, so that is my lowercase c. At this stage, I'm not going to label my capital B, my lowercase b, because as I just said previously, I don't actually need all three to be able to work it out. So to apply the formula, I'm looking for a length, so I'm going to use C over sine C is equal to A over sine A. Now to fill in the information that we know. So C, little c or lowercase c, is x over sine of uppercase C, which is 48. From the formula, we know that this is equal to my lowercase a, which is 16, over sine of my uppercase A of 70. We now need to rearrange this to make x the subject, so I'm going to multiply both sides by sine 48. I then can write x equals 16 over sine 70 multiplied by sine 48, and then I can type this into my calculator to give me a value of x. I get a value of 12.65341128. Just run that to three significant figures. I get 12.7 centimetres. My second example, this time I'm asked to find the value of an angle. So I'm going to now label my lowercase letters. Opposite my capital B is 17, so I'm going to label that B. And then the 21 is opposite my uppercase C, which I'm going to label lowercase c. So again, I'm trying to find an angle, so I'm going to use sine B over lowercase b is equal to sine C over lowercase c. To fill in the information that I know, I do not know what the capital B is, so I'm going to leave that as theta. I know lowercase b is 17. That is equal to sine 105 over 21. Just as I did last time, I need to rearrange. I'm going to make sine theta the subject, so multiply both sides by 17. I end up with sine theta is equal to sine of 105 over 21 multiplied by 17. Now, the question already stated at the beginning that it wanted the value of theta, not the value of sine theta as I've left it here. So what I need to do is I need to get rid of the sine function from my theta, and to do this I need to inverse sine both sides. Therefore, I write theta is equal to inverse sine of whatever this is, sine of 105 over 21 multiplied by 17, and I get inverse sine. So shift and the sine button will get you the inverse sine. Insert my fraction button, sine of 105 over 21 multiplied by 17, close that bracket at the end, and I get this value here. Theta is equal to 51.4385406. Theta equals 51.4 degrees to three significant figures. Degrees because it is an angle. My final example for you for the sine rule question is another angle question. It's asking you to find the value of theta. So I'm going to label my sides. Lowercase a opposite my capital A. Lowercase b opposite my capital B. And my uppercase c opposite that is my lowercase c. So this time I do know this pair of opposites, and I'm looking to find this angle here, but I do not know the length here. What I can do is use my B and work out the angle here, and once I know this angle here, I can then simply do angles in a triangle add up to 180 degrees, and therefore subtract these two from 180 degrees, which will leave me with that. So I'm looking for angle B. So sine B over lowercase b is equal to sine A over my lowercase a. Again, I cannot use C because I do not know the information here. Filling in the information that I do know, so sine capital B over 7.5 is equal to sine 56 over 6.3. Multiply both sides by 7.5. I get sine B is equal to sine 56 over 6.3 multiplied by 7.5. As you saw in my previous example, what I'm going to do is I'm going to inverse sine both sides. Inverse sine. Now what I'm going to do is type this into my calculator, so I get sine 56 over 6.3 multiplied by 7.5. That gets me that answer. What I'm going to do is I'm just going to write inverse sine of the answer, and what I can say is B is equal to inverse sine, and then if I press the answer button on my calculator here, it will just use the previous answer that was just on my calculator, which is what this calculation was. When I do that, I get 80.73330645. Now I wasn't asked for angle B in the original question, I was asked for theta. The question asked me to find the value of theta, which is down here. As I said earlier, I'm now going to use my angles in a triangle, add up to 180 degrees. So I'm going to do 180 minus 56 plus 80.733, etc. Please, please, please make sure you do use the full value in your calculation. So 180 minus 56 plus that answer gets me 43.26669355. Theta equals 43.3 degrees to 3 significant figures. Okay, so now on to using the cosine rule. I've already labelled the triangle with my capital letters and my lowercase letters. So now I want to introduce to you the formula for the cosine rule for a missing length and for a missing angle. So the formula for a missing length is a squared is equal to b squared plus c squared minus 2bc cos a. And to find a missing angle, it's cos a is equal to b squared plus c squared minus a squared all over 2bc. All this is a rearrangement of this formula. If I add 2bc cos a to both sides and subtract a squared from both sides, I would be left with 2bc cos a is equal to b squared plus c squared minus a squared. To get this 2bc underneath here, it would be here, so divide 2bc on both sides to get this final rearrangement. Please make sure that you make a note of these two formulae, as you will not be given them in the exam and you are expected to learn them. What I'm going to do is show you two examples as to how to use these two formulae. First example, ask me to find the value of x. As you can see, x is a length, and therefore I need to just make sure I label my sides. So opposite capital A is my lowercase a, opposite my capital B is my lowercase b, and opposite my capital C is my lowercase c. I'm looking for a length, so I'm going to use a squared equals b squared plus c squared minus 2bc cos a. Filling this in, a is x, so I get x squared is equal to 10.7 squared plus 13.2 squared minus 2 times 10.7 times 13.2 times cos 43. Type that into my calculator. I get the result of 82.137,206.37. Now this gives me x squared. I'm asked for x in the question. So to do this, I'm going to square root the previous answer that I have that's already on my calculator. So I'm going to square root that answer, which gets me 9.06295796. Just going to round that to 3 significant figures, not forgetting my units either. My second example. In this example, I'm asked to find the value of theta. So this time I'm looking for an angle. I've written this formula here because, as you may notice, I'm looking for angle B. My formula is written in the form cos A, so this would suggest that I'm actually looking for this angle up here. Now in the exam, they may already have labelled your triangle for you. What you need to be able to do is to just make sure that you're able to substitute your values to make sure that you're finding the angle that you are after. There's two ways you can do this. You could either cross this out and change this to capital A, and cross this out and change this to capital B. Or what you can do is, with your formula, for every time that you see an A in your formula, you replace it with B, and every time you see a B in your formula, you replace it with A. I'm going to show you by resubstituting in the values into the A and the B, etc., to show you how that works, rather than just crossing it off. But crossing it off and swapping them at this stage is absolutely acceptable as well. So I'm looking for cos B. I've swapped that A for capital B. Now this lowercase b I'm going to swap for a lowercase a. The c is going to stay the same, and the lowercase a is now going to become a lowercase b. That is then all over. Two lots of swap the b for an a, and the c remains the same. Now I can just use this as a formula, so substituting the values that I know. Cos theta is equal to, I haven't labelled my sides just yet, so a, this must be lowercase a, b, this must be lowercase b, and c, this is lowercase c. Going back to my formula, I've got a squared, so that must be 14 squared, plus c, which is 9.3 squared, minus b, which is 11.6 squared, all over 2 times a, which is 14, times c, which is 9.3. Again, like I had with the sine example, I'm not asked for cos theta in the question, I was asked for the value of theta. So to do this, I'm going to inverse cos of the answer that I get when I type this into my calculator. So typing this into my calculator, I'm going to use my fraction button. 14 squared plus 9.3 squared minus 11.6 squared over 2 times 14 times 9.3. That's the answer that I'm going to use at this stage. To do that, shift cos to get inverse cos, the previous answer that I've just typed in from here, and that gets me a value of theta of 55.383,02729. So you now know the cosine rules and the sine rules. How do I know when to use each of them? So to use the sine rule, it's used when an angle, to find an angle, when the opposite length is known and another pair of opposites are known. What I mean by this is when I have a pair of an opposite length and an opposite angle. Vice versa, to find a length, I use this when I know an opposite angle to the length that I'm looking for and I know another pair of opposites. So just to show you, if I'm looking for this angle and I know this length, I need to also know another pair of opposites. Or to find a length, if I'm looking for this length, I need to know this angle and another pair of opposites. For the cosine rule, to find an angle, I need to be able to have all three sides known. So to find the angle, I need to know all three sides to find any angle. To use the cosine rule to find a length, I need to know two sides, the angle between them, and I need to be looking for the length that is opposite the angle that I know. Okay, just to finish off then, I have a few final examples where I have a mixture of sine and cosine rule questions. My first example here asks me to find the value of theta. So what I'm going to do is I'm going to label the theta capital A and consequently little a, lowercase a, opposite that. My next angle that I know, I'm going to label capital B, which I will label that, lowercase b. So I know a pair of opposites and I also know the length opposite the angle that I'm asked to find. So what I'm going to use here is the sine rule. Sine A over A equals sine B over B. Sine theta over 8 is equal to sine 32 over 5.7. Multiply both sides by 8 to get sine theta the subject. And now to get rid of the sine from the theta, I'm going to inverse sine of both sides, which will leave me with inverse sine of this answer that I'm going to have on my calculator. So sine 32 over 5.7 multiplied by 8 gets me that answer there, which I now need to inverse sine that answer that I've just typed into my calculator to give me a value of 48.05153138. Theta equals 48.1 degrees to 3 significant figures. Sorry. My second example, asking me to find the value of x. The angle that I know, I'm going to label as A, and therefore the length that I'm looking for is A, little a. I'm not given the angle here or here, so it doesn't matter whether I label them B or C, as long as I label the opposite to what I've got, capital, lowercase b and lowercase c. I'm looking for the length opposite an angle where I know the two sides either side of, and therefore I'm going to use the cosine rule. The cosine rule, a squared equals b squared plus c squared minus 2bc cos A. So lowercase a is x, so I get x squared is equal to 15 squared plus 19 squared minus 2 times 15 times 19 times cos 71. Type that into my calculator. I get 400.426152. To find x, I square root that answer that I was just given. So x is equal to 20.01065.096. So I get 20 centimetres to 3 significant figures. And finally, in this example, again, nothing is labelled, so I'm going to label that. I'm going to label the angle that I'm looking for A, the other angle that I know B, and therefore the final angle I'm going to label C. Label my lowercase letters. This is lowercase a, lowercase b, and lowercase c. Looking at this, I could use the cosine rule if I really wanted to, but I think it's probably easier to use the sine rule because I do know a pair of opposites and I do know the opposite length to the angle that I'm looking to find. Therefore, I'm going to use sine A over lowercase a equals sine B over lowercase b. Sine theta over 7.5 is equal to sine of 103 over 11.8. Multiply both sides by 7.5. I get sine theta is equal to sine of 103 over 11.8 multiplied by 7.5. Type that into my calculator. Sine 103 over 11.8 multiplied by 7.5. To get theta, I need to do inverse. So inverse sine of the answer that is on my calculator, I get 38.26525422. Theta is 38.3 degrees to 3 significant figures.